Welcome to this explainer, where we're going to unpack a massive, fundamental shift in artificial intelligence capabilities. But more importantly, we're going to explore the critical, layered defenses we absolutely need to secure our systems right now. If you've been following the rapid evolution of frontier AI models, you know the deal. We've crossed a threshold. We are way past simple chatbots now. We're dealing with autonomous, cyber-capable agents, and that shift literally changes the entire game for cybersecurity.
To really grasp what we're up against, I want you to picture an illustrative scenario the source material calls the quiet pivot. Imagine it's mid-2027. A state-aligned actor takes an open-weight AI model, one that has converged on commercial frontier capabilities, and deploys it against a federal agency that's right in the middle of migrating its post-quantum cryptography. Because this AI uses multi-step agentic reasoning, it quietly plants a credential harvest in the agency's pipeline over a multi-day arc. And the wildest part? Against a traditional defensive posture, it stays completely undetected. Our old safety controls just aren't calibrated to see it happening.
So, to understand how a structural failure like that quiet pivot happens and how we can decisively stop it, we're turning to Robert Campbell's rigorous, peer-reviewed reference architecture. This paper, which was published in Computers, develops a highly detailed defense-in-depth response to what we now call Mythos-Class frontier model capabilities. It's not just theory, it's a literal blueprint for survival.
Here is our roadmap for the explainer today. We're going to define the Mythos-Class threat, look at why old defenses are failing us, break down the 5 warning indicators, map out the 3 zones of attack, and finally, build out a brand new defense architecture. Okay, let's jump right into Section 1, the Mythos-Class threat.
The term Mythos-Class actually kicked off around April 2026 with Anthropic's Claude Mythos preview, which showed off multi-step autonomous cyber operations that totally blew past all prior generation models. But there's a really interesting debate here. Researchers at the AI Security Lab Europe, or ASIL, argue the AI model itself isn't the primary issue. They actually proved this by reproducing high-level cyber capabilities using a much smaller 3.6 billion parameter open-weight model, just by holding the agentic scaffolding constant. They hit the nail on the head with this quote: "The moat in AI cybersecurity is the system, not the model." While some people use that to say the threat is overstated, it actually proves the exact opposite. Because open-weight versions spread like wildfire, usually within months, capability just isn't kept behind closed doors anymore. Our defenses have to evolve to protect the entire system, because we simply can't rely on gating access to the model.
Which brings us perfectly to Section 2, why old defenses fail.
Here's the terrifying realization. Our dominant AI safety measures have a massive blind spot. Traditionally, we relied heavily on RLHF, or reinforcement learning from human feedback, and output filtering. But those were built for single-turn interactions. You ask a chatbot a question, it filters the direct answer. Mythos-Class AI doesn't work like that at all. It uses multi-step reasoning. It might take 30 distinct actions to achieve a goal, and every single intermediate step, like searching a directory or formatting a string, looks completely harmless to a filter. By the time it spits out a definitively dangerous output, the operationally relevant computation is already done. The damage is done.
And our other pillars of safety? They fail just as dramatically. Contractual access vetting, basically making sure only the good guys buy your AI, that fails the second open-weight diffusion hits the internet, which happens incredibly fast. And traditional human-in-the-loop supervision? You literally cannot stick a human in the loop of an agent making hundreds of micro-decisions a minute. The speed and depth of these chained actions just completely blow past human review capacity.
So, moving on to Section 3, the 5 warning indicators.
If the old safety nets are full of holes, how do we actually spot these capabilities before it's too late? The author lays out a very clear operational definition with 5 measurable indicators. First, capability. Is it beating prior baselines on cyber ranges? Second, the scaffold. Does it have the infrastructure to use tools and self-correct? Third, access pattern. Can it be invoked outside vetted regimes, like an open-weight model? Fourth, autonomy depth. Can it chain tens of actions without needing a human checkpoint? And finally, persistence. Does it retain memory across different sessions? Now here's the kicker. A system only becomes a Mythos-Class threat when all 5 of these compound together simultaneously. It's a moving target. A system might hit 4 today and become Mythos-Class tomorrow just because an open-weight equivalent drops.
All right, Section 4, 3 zones of attack.
Once those 5 criteria are met, where does the threat actually strike? There are 3 distinct trust boundaries an attacker might cross. First, you have the external adversary. This is a hacker using their own self-hosted AI totally outside your control surface. Second is supply chain integration. This one is insidious. It's when a compromised AI is baked right into your automated stack and looks completely legitimate internally. Third is authorized user misuse. This is your insider threat, a vetted user or someone with stolen credentials running the AI outside their declared scope. Point-in-time access controls just can't catch this. You absolutely need continuous behavioral monitoring.
Which leads us to the solution. Section 5, a new defense architecture.
Since we know single, isolated defenses fail against these attacks, we need a Swiss cheese defense-in-depth approach. We're stacking multiple imperfect layers to create a solid wall. The very first slice is VAOP, or the Vetted Access Operational Pattern. This is essentially your governance layer. It provides organizational vetting before anyone even touches the system. Now, we know open-weight models eventually bypass this, right? But the paper argues it acts as a critical bridging layer. It buys your organization the vital time it needs to set up the harder technical controls.
Next up is the absolute powerhouse of this architecture, ABOR, or Authority Bound Output Release. This is your cryptographic enforcement layer. If a Mythos-Class AI cooks up a dangerous script, ABOR ensures it physically cannot be executed on your network unless it's cryptographically bound to a verifiable authority chain. And I love this detail. Campbell's architecture specifies using FIPS 203, 204, and 205 post-quantum cryptographic primitives. So we aren't just securing against today's AI, we're actually future-proofing against tomorrow's quantum computing threats.
But what about that supply chain attack zone we just talked about? The call coming from inside the house? Well, to protect that internal zone, ABOR ties directly into MB-OPM PQC. Think of this as a continuous cryptographic paper trail that structurally tracks the origins of every single AI dependency. If a compromised piece of code tries to do something malicious, its corrupted runtime context gets flagged immediately, isolating the systems it tried to reach.
Layer 3 is CPIP, the Compute Plane Isolation Profile. Think of this like the physical bulkheads on a submarine. It's a strict architectural wall that gates the tools, APIs, and network surfaces the AI is allowed to interact with. If an attacker tries to use prompt injection to make the AI ping a malicious server, CPIP is the exact wall that stops that network request dead in its tracks.
And finally, tying the whole shebang together is the brain of the operation. MCPR, the Mythos-Class Posture Rubric. This isn't just a one-and-done test. It's a continuous, three-tiered detection framework running across evaluation, deployment, and runtime. It's constantly watching for those 5 warning indicators we talked about. The second it detects a shift, like an authorized user suddenly acting evasive, MCPR explicitly routes that threat straight to our mitigation layers, like ABOR and CPIP, to shut it down completely.
So I want to leave you with this final, provocative thought. The moat in cybersecurity is no longer about keeping the AI model hidden. It's entirely about how robust your system architecture is. As these autonomous, multi-step AI capabilities rapidly make our old safeguards totally obsolete, the clock is absolutely ticking. Are you prepared to build the layered, cryptographically enforced architecture we need to survive tomorrow's threats? Because this is the new frontier of defense, and it requires action today. Thanks so much for joining me on this explainer, and definitely keep your systems secure.